Spur gears rank among the most widely used precision cylindrical gears due to their straightforward design. They consist of straight, parallel teeth arranged around the circumference of a cylindrical body with a central bore that fits snugly over a shaft. Some variations of spur gears incorporate a hub, adding thickness to the gear body around the bore while keeping the gear face unchanged. Spur gears find applications in various industries, including transmissions, conveyor systems, speed reducers, gear pumps and motors, and machining tools. Thanks to their advantages of a simple and compact design, constant speed drive, reliability, cost-effectiveness, and efficiency. Helical gears are mechanical components that transmit motion and power between two parallel shafts. They are called helical gears because the teeth on the gear are inclined at an angle to the face of the gear rather than being perpendicular to it. This design allows the gears to mesh smoothly and quietly, making them ideal for many applications. Helical gears are versatile and can be used in various applications, from automotive transmissions to industrial machinery and robotics. One of the significant advantages of helical gears is their versatility, as they can be used with both parallel and non-parallel shafts, making them suitable for a wide array of applications. Additionally, helical gears offer smooth gear operations, resulting in reduced shock loads and lower noise levels compared to other gear types, making them ideal for applications where noise reduction is crucial. A double helical gear, also known as a herringbone gear, is a specialized type of gear that combines the characteristics of helical gears while addressing the axial thrust issues found in single helical gears. It is made up of two mirrored helical gear sections with opposite helix angles, positioned side by side and meshing with each other. The helix angles on each side of the gear are oriented in opposite directions, resulting in tooth profiles resembling the letter V when viewed from the end. This unique design enables the double helical gear to efficiently and quietly transmit rotational motion and power, similar to standard helical gears. Double helical gears offer a host of advantages, including a high load capacity, reduced heat buildup due to their large number of teeth, smooth gear operations, and enhanced durability. These benefits make them well suited for applications in heavy machinery, industrial equipment, automotive gearboxes, and power transmission systems. A bevel gear is a toothed, rotating component utilized for transferring mechanical energy or shaft power between intersecting shafts, which can be either at a right angle or an inclined angle. This gear type causes a shift in the axis of rotation of the shaft power. In addition to this primary function, bevel gears have the ability to alter torque, either increasing or decreasing it, while simultaneously affecting the angular speed in the opposite manner. Bevel gears, with their advantageous features, find widespread applications in locomotives, marine systems, differential drives, and rotorcraft drive systems. Their compact and space-efficient design makes bevel gears particularly suitable for installations with limited space constraints. Additionally, they excel at efficient power transmissions, ensuring smooth and reliable performance in various applications. Moreover, bevel gears possess self-aligning properties, contributing to their ability to accommodate misalignments, thereby enhancing their overall durability and reliability in demanding environments. A worm gear is a type of gear mechanism comprising a shaft with a spiral thread that meshes with and drives a toothed wheel. It is considered one of the 6 simple machines and has been used for a long time in various applications. Essentially, a worm gear resembles a screw in contact with what appears to be a regular spur gear featuring slightly angled and curved teeth. The primary function of a worm gear is to change the direction of rotational movement by 90 degrees. As the worm engages with the worm wheel, the plane of movement also shifts due to the positioning of the worm on the worm wheel. This unique arrangement allows for effective power transmission and is commonly employed in situations where a right-angle drive is required. Worm gears offer several advantages, including the ability to achieve higher speed reductions, silent operation, self-locking characteristics, and greater torque output, making them valuable components in various applications. Their efficiency in achieving significant speed reductions makes worm gears ideal for applications like conveyor systems, automotive components, elevator lifts, and textile machinery, where controlled and precise motion is required. Additionally, the silent operation of worm gears ensures reduced noise levels, making them suitable for applications where noise reduction is crucial. A rack and pinion gear is a type of gear mechanism used to convert rotational motion into linear motion or vice versa. It consists of two main components, a straight, flat gear called the rack, and a round gear called the pinion. The rack. The rack is a linear gear with teeth along its straight length. It resembles a long, flat bar with teeth running along one edge. The teeth on the rack mesh with the teeth on the pinion. The rack is fixed in place, typically secured parallel to the intended linear motion. The pinion. The pinion is a small, round gear with teeth that mesh with the teeth on the rack. It is mounted on a rotating shaft, and when the shaft rotates, the pinion moves along the length of the rack. Their precise linear motion capabilities make rack and pinion systems ideal for use in steering systems of automobiles, ensuring accurate and responsive control for a smooth driving experience. Moreover, their high efficiency in converting rotary motion to linear motion helps enhance the overall performance of various mechanisms. In addition to their precision and efficiency, rack and pinion systems offer a high load capacity. Furthermore, their self-locking feature provides additional safety and stability, ensuring that the system maintains position without the need for constant power input. Addendum. The addendum of the gear is the distance between the pitch circle and the tooth tip circle. Addendum circle. A circle drawn from the top of the tooth and concentric to pitch. The addendum circle for external gears is on the outside cylinder, whereas the addendum circle for internal gears is on the inside cylinder. Dedendum. The dedendum of a gear is the distance between the pitch radius and the root radius at the center of one gear tooth. Dedendum circle. A circle drawn from the bottom of the teeth and concentric with pitch circle. The dedendum is the radial between pitch circle and dedendum circle. Top land. The top land of a gear tooth is its top surface. Face width. It is the axial distance from one end of the gear tooth to the other end, measured along a line parallel to the gear axis. Tooth thickness. The arc length between opposite faces of a tooth, measured around the standard pitch circle, is the tooth thickness of a gear. Because this length cannot be measured directly, a different gear dimension is measured instead, and the tooth thickness is calculated from there. Circular pitch. Circular pitch is the distance between a location on one tooth and the equivalent position on the next tooth, measured around the circumference of the pitch circle. Pitch circle. A pitch circle is an imaginary circle that would produce the same motion as the actual gear through pure rolling motion. The size of pitch circles for a given pair of mated gears fluctuates with center distance because they are imaginary by nature. Clearance and clearance circle. The space between the gear's outside diameter and its mate's root diameter is known as clearance. This margin compensates for thermal expansion during operation and avoids a gear tooth's top from interfering with the root of its mate gear tooth. A circle passing through top of the meshing gear is known as clearance circle. Face. The working surface of the tooth above the pitch circle is referred to as the face of the tooth. Flank. The working surface between the pitch circle and the bottom land, including the gear tooth fillet, is known as the tooth flank. Tooth space. The tooth spacing is the distance between two consecutive teeth measured around the circumference of the pitch circle. Working depth is the radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. Backlash. This is the amount by which the width of the tooth spacing exceeds the mating gear's tooth thickness.